Hello, everyone, and welcome again to the n-Lorem podcast series. I'm Stan Crook. I'm your host for the podcast series, and I'm chairman and CEO of n-Lorem. We're delighted today to have a colleague and friend, Jeff Carroll, join us. Jeff is an associate professor of neurology at the University of Washington Medical School, and he has served as a consultant to n-Lorem since the first day we opened our doors, and invests a great deal of time and energy in helping us understand whether the applications that we receive on any particular day, whether that application is something that we can develop an ASO for and treat that patient or not. So, Jeff, welcome.
Thanks, Dan. It's a pleasure to be here.
Yeah, and so, Jeff, just to begin, I think you're a West Coast boy from, I should say conception, not inception, I guess.
Yeah, born and raised, let's say.
Yeah, in Washington.
Yeah, that's right. So I grew up I was born just south of Kent. There's just south of Seattle, a town called Kent, and grew up there my whole life. My family didn't have a ton of money or anything, so we didn't travel very much. I was very kind of insular before I got out and saw the world later in life.
Yeah, and learned you may want to just stay home.
Well, the thing is, once you grow up in the Pacific Northwest and you go everywhere else, you think, everything is a mission to get back home.
Makes it, yeah. And you're from a large family. Is it a really close-knit family? You stay in touch with all your siblings and all that?
Yeah, absolutely. So there's 6 kids in my family, and we were all, 18 months apart or so. So we grew up very much in each other's hair. My family, we didn't have a ton of money, and we had a relatively, we had a nice house, but a small house. And we grew up, 2 of my sisters, we always joke, shared a closet, although in retrospect, it wasn't actually a joke. Like, they lived sort of a modified walk-in closet and some bunk beds. And I always had, I've actually literally never had my own room, I realized. So, maybe someday when I retire, I'll get my own bedroom. That's my life goal. But yeah, so basically we had a small, us being so close in age, we got along really well and stay in touch. I just saw a bunch of them. So yeah, being close to the family is great, and still very much involved with all of them.
That's great. And then you went to high school, and from there, maybe by choice, maybe not so much by choice, you entered the Army. Is that right?
Yeah, I was very much not the going to join the Army. If you picked the kid in high school who's going to go in the Army, who was doing ROTC or something, I was the opposite of that. So my best friend and I were making some poor life decisions, and we were having a cigarette on his mom's porch, and he turned to me and he said, "I think the most punk rock thing I could do is join the Army." So he had this whole idea that he would kind of get away from his kind of life choices that were sort of not in the best path, was by just resetting the whole thing and joining the Army. And I was kind of in a similar place, and I always joke that it wasn't exactly like go to the Army or go to jail, but it was in that neighborhood. And it actually was great for me. So he and I joined together. Classic story. We joined together. They have this thing in the Army called the buddy program, and we thought we'd be together all through our first duty station. The first day off the bus, he went left and I went right. Never served together again. We stayed in touch, but weren't together. But nevertheless, like the Army was great for me. I got in shape. I got some discipline. People stopped taking my crap and just made me do stuff. And it was a huge help for me. So despite its my inauspicious beginnings, I guess, it ended up being a really good grounding for me before I decided what to do with my life.
Well, that's great. Although it sounds frankly insane to me, but okie dokie.
Oh, it was.
And I'm disappointed to hear that Stripes isn't for real and you don't get to go with your buddy when you join, but okay.
No.
And then you served in Kosovo.
Yeah, so in
Were
1998.
you in a combat unit or?
Yeah, so at that time, I actually had been stationed in Germany, so I spent 3 years in I was in a station. I had joined the Army to get technical skills, and so I was a communications guy nominally, but I kept getting assigned to combat arms units. So I was in an infantry battalion for a year here in the U.S., and then I was in Germany and Kosovo for 3 years in a tank battalion. So even though I didn't want to do all this G.I. Joe stuff, I ended up in these units where I was running around tanks and fixing radios and doing all that kind of stuff. That was much more Army-like than I wanted. And when I was in that tank battalion in Germany, this was kind of the tail end of the Balkan War, and Kosovo was the last place where there was this kind of threatened genocide, and there was some really bad stuff happening, and the U.S. was bombing Serbia to kind of try to get the Serbians out. And my unit was actually in Germany, and we had a mock-up of the border, and we were running the border over and over again in case the air war didn't work. And then ultimately the air war did work, and we went back in as peacekeepers. So I spent the turn of the millennium in Kosovo in a sea hut, which is what we called these like plywood huts that the Navy would build for us. So I'll never forget where I spent the millennium.
Well, at least you didn't have to worry about the computers going down, I guess.
No, it's true. No, I had all the guns, so it wouldn't have mattered if they did. It was fine.
Well, it sounds interesting. And of course, your life changed a lot. Probably, as I understand it, sometime while you were in Kosovo or while you were in the Army. Why don't you tell our listeners about that?
Yeah, so right just before I deployed to Kosovo, which was great timing, I found out that my mom was not only at risk for a disease called Huntington's disease, but in fact that she was sick. And she was actually to the point where the reason it came up is she was not able to live independently anymore. My parents were split up, and so the family suddenly had this thing to take care of. And my wife, who I'd been married to for a few months at that point, my dad sat her and I down in the kitchen and said, Jeff, your mom has Huntington's disease. And I freaked out, which means that on some level I must have known what Huntington's disease was. It's a terrible autosomal dominant, fully penetrant fatal disorder that my grandmother had ultimately died from. But my family had told me when we were young that we didn't have to worry, and that it skipped a generation. There was some story that was not correct science that made my generation not worry about it. We thought we were fine. My wife literally didn't know what it was because I never told her because I didn't think I was impacted. But now all of a sudden, my mom was sick. All 6 of us were at risk of 50% chance of inheriting this disease. And my wife was suddenly getting a crash course in, my family. And so I spent Kosovo. I really just tried to, I was on the internet. It was terrible then. I mean, still pretty bad, but the resources were awful. And so it was in Kosovo that I sort of thought, well, when I get out of the Army, because I always knew I'd get out after my 4-year tour, that I'll go get in my undergrad, I thought I'd go to do philosophy and then do a law degree or something. I don't know what my plan was exactly, but I thought, well, I'll take some biology courses when I get out. And that was where that kind of resolve came from, of that frustration in Kosovo of not being able to find out any good information. And what was out there was really terrifying.
Yeah. So just to step back for a minute, Huntington's disease, I think probably most people know of it. Of course, Woody Guthrie was the most famous sufferer of Huntington's disease, and it's a member of a disease family called triplet repeat diseases. And what that refers to is, as you know, the genetic code is 3 letters, and for reasons that are not really fully clearly worked out biochemically, there are certain combinations of genetic letters that are sticky. And the enzyme that's responsible for making new copies of DNA, DNA polymerase, gets stuck, and it's like a typewriter going back over and over again, typing the same 3 letters. And as a result, then over generations and generations, the length of those repeat segments grows. And at some point, they become large enough that either the RNA or the protein that's produced, or maybe both, can cause significant death of neuronal cells, and in particular neuronal cells. And as a result of all that, then patients undergo dementia. They can become psychotic, frankly psychotic. They have movement disorders, and they rapidly progress after the symptoms arise to death. Is that a fair summary of what you face?
Yeah, well, and of course I didn't know all that then, sort of do now, but
you do.
yeah, but that was, and the scary part of that became clear to me. The same with every family in this situation. You learn the terrible stuff first, and my mom was sick, and her relationships with other family were fragile and already, and so when you throw on this progressive, especially the irritability and the rages and stuff like that are common to people with many kinds of progressive dementia, I mean, it's very debilitating for families, even in the in the quote early stages of the disease, which is ultimately fatal, as you say.
Yeah, it certainly is, and it's and every person who has to deal with knowing that he's at risk deals with it in a different way.
Right.
But before we leave the disease, there's a term that I want to introduce, and that's called anticipation.
Mm-hmm.
And all that refers to is that every new generation tends to accumulate more of these triplet repeats. And the longer the triplet repeat length, the earlier the disease is likely to happen and the more severe the disease.
That's right.
And so as the idea that it would skip a generation is particularly diabolical, because it does the opposite. Every generation, the risk gets worse.
Right.
And so let's talk about that. You're in Kosovo, you learn it. Over time, you're able to figure out that this is not a good thing at all.
Right.
How do you manage through that, Jeff?
Yeah, I mean, you're exactly right. Everyone's different, and for very good reasons. Different people cope different ways, healthy, and for me, like, I'm a little bit obsessive, and so like I was going to be thinking about it anyway, and I was fortuitous that I had a reasonable brain that like wasn't being accounted for yet. I wasn't doing anything with it yet, and so I had time to decide at a sort of a inflection point in my life of like, what do I do? And I thought, well, I'm going to be thinking about this anyway. I might as well try to work on it a little bit. I didn't have any idea. I'd never met a scientist. I didn't know that people did science and got paid for it. I had no clue that was a job. All I thought was like, I want to know more. I'm starting my undergrad. I'll take a few biology classes. I had none of the prerequisites. And the nice woman at the registration was like, you can't possibly take these classes because you haven't taken anything since like 9th grade. And I talked my way into it. I got good at that in the Army, and I was like, okay, well, I'll take responsibility, and I had a bad first year, but I loved it. And everything I learned about biology in particular, I just found it really fascinating. And at the same time, I found out that a guy called Michael Hayden, who's a key player with n-Lorem, he's on the board, and I know a longtime colleague and friend of yours, Stan, who was ultimately my Ph.D. supervisor, just happened to have his lab in Vancouver. So it's another one of these, like, if all of these lucky things hadn't lined up, there's no way I would have been doing science. But even as an undergrad, Michael's quite a famous figure, especially in UBC. And so as people learned that I was interested in Huntington's, they sort of said, oh, science people and disease people said, oh, there's this great HD lab here. And ultimately I met Michael, although I met him in kind of a funny way, which is that at UBC, when I was an undergrad, I underwent predictive testing. So Huntington's is 100% penetrant dominant disease, meaning that if you have the mutation, you're going to get it eventually. And if you don't, you won't. As you said, it doesn't skip a generation. And so you can undergo what's called predictive testing, which is when you don't have symptoms, but you want to know what your fate is ultimately. And once I knew that was a possibility, I couldn't imagine not knowing. It's just me. And so I signed up for predictive testing as soon as I could. And I happened at Michael's clinic, although just fortuitously, for some strange reason, I, through luck of the draw, didn't get Michael, who does almost all of the predictive tests. I got one of his colleagues, and unfortunately learned that I carry the same mutation as my mother, and so ultimately would be expected to have the same kind of onset and prognosis as her. And my wife tells the story that I asked him for a job, which is basically, I said, cool, like, I want to help. Could you help me? Could you introduce me to Michael? And he did. And so I think a couple months later, I still have on my calendar, I went and met with Michael and laid this out for him and said, listen, I'm just going to be thinking about this anyway. I want to be involved. And to his credit, he said, listen, you can do anything you want. This doesn't have to define you. But he also said, if this is what you want to do, I'm happy to support it. And he let me come in as an undergrad and, circulated around projects and kind of just shadowed people and just never left, like transitioned from my bachelor's to my PhD and stayed there for a long time. So, throughout, like, the news has been bad, but like turning towards it has led to like really exciting things that I don't think I would have ever been capable of if I hadn't had these challenges,
one of the really difficult decisions to make with an inherited genetic disease is, do you have children?
Huge.
And how did you and your wife work through that horrible dilemma?
Yeah, it was horrible. I mean, so we underwent. So we again lucky we got underwent predictive testing in Vancouver, which follows like the best standards of predictive testing. So we had a delay built in. We had counseling on either end. We had a genetic counselor help us talk through issues. It was the gold plated kind of experience you want people to have. And as part of that, the counselors asked us, do you want to have kids? And I said no immediately. And my wife was like, oh, well, I guess we're not having kids. And so that was it. I shut her off because I couldn't imagine, wanting to do it. And as life went on, and my grandfather, who was a very beloved figure in my life, he passed away at glioblastoma in his 80s. And he was a huge figure for me. And when he died, I started thinking about legacy and kids, the way you do. And at that time, there was this new thing called preimplantation genetic diagnosis, or PGD, which is basically like in vitro. It is in vitro fertilization, but at the 2 or 8 cell stage, a cell is grabbed and genetically tested, and you can basically tell which embryos are affected and which aren't. It was experimentally done a lot. There had not been anybody doing it just commercially, just like off the street in Vancouver at that point. There was a clinic that wanted to try it. And we pursued it, and we have 2 kids who are now 17-year-old twins who, went from 50% chance if we'd done it naturally to, pretty close to 0, which is how we dealt with it. But not everybody has, the education, the resources, the money, all those things to make that happen. So it's a really hard decision for families.
Yeah. And is that procedure now available commercially for folks?
Much more widely, and it's improved a lot. So I've had friends go through it more recently, and when we did it, they had the embryos in the room in the incubator, and you have to decide on the spot. We had 2 embryos, and they sort of said you've got to go or not. Now they freeze the embryos, and so you can do another cycle, and it's more calm. And there's a lot of improvements, and it's great, and something I hope a lot of people from genetic families all think about doing.
Yeah, and genetic diseases come in 2 forms: inherited and de novo. Are inherited and a bunch of bad luck.
Mm-hmm.
And for inherited diseases that are as well inherited as something like Huntington's, and there are a good many triplet diseases. It's something that I think probably helps many people make these life decisions that obviously you also have to weigh your ability to be the wage earner and the caregiver and all that at some point in your life.
Absolutely. Yeah, and it's one of the reasons I've been very open about this stuff, just because it's my personality, but also I've met multiple people now who've showed me pictures of their kids after I gave a talk at the Huntington Disease Society of America one year and mentioned PGD, and someone told their kids and their kids. So it's it's part of my mission to try to let people know there's options for families.
Well, as maybe many people know, at Ionis, we have had a major program in Huntington's disease, and we're developing actually a couple of ASOs, but the lead ASO had completed a very large set of clinical trials, almost 800 patients, followed for about 59 weeks as a minimum with our Huntington ASO. And now Roche is going back and doing an additional clinical trial, which is usually pretty much the way it has to go. First clinical experiments usually are not designed right to get you the answer you need. And so that's going on. Is that how you got connected to Ionis?
Yeah, that's exactly right. So I was in Michael's lab, and Michael, I think you and Michael have been working too on liver, like from other situations, and I mean it was very novel at that time to me, the idea that I'd finally learned that everything bad that's happening in HD is due to the expression of this one mutant gene. And it's fortuitous. It's like you said, a whole horrible bad luck. 4 of my siblings inherited it, 2 didn't, and it's luck of the draw. It's 100% unfair luck. But if you don't have it, you don't get sick. And that really means that something like an ASO, where you can lower levels of a given gene, in this case, of course, the mutant Huntington gene, it's such an obvious good idea, and all the mouse trials have told us it's a good idea, et cetera. So watching that develop has been, such an incredible joy for me. And that started very early on in my time when I was in the lab at UBC, and got involved with a number of scientists from Ionis who were working in that program, including Frank Bennett, who was coming up to Vancouver, and we were doing a lot of early mouse work to try to figure out how do you model this stuff in mouse models, which is how we do things in HD, and got involved very early on, and then have always stayed close to it. So I'm not a clinician, I'm a basic scientist, but as it kind of passed out of my grasp, I always wanted to stay involved with it, and it's hard for me to explain. I can't explain what it's like, what it was like and has been like for the HD community to watch the Huntington lowering, which is what we call this ASO approach of lowering the mutant gene. It's been like, every rare disease family knows that the worst conceivable thing ever has happened to you. No one can help you. No one can change everything. Everyone's dying in these horrible ways. And then there's a glimmer of light that you didn't even know was possible, that yeah, this is horrible, but also maybe, just maybe, there's a way that you could reduce the thing that's causing all this bad stuff. It's hard to explain to someone who hasn't been through that process. And as a community member, watching that with Ionis, who really drove that, there's other companies doing less established approaches now, but Ionis was really the pioneer there. It changed everything. It's still incurable. We can't change it yet. We'll get there. I believe it, but going from impossible to possible changes everything, and that was such a joy to watch that develop.
Yes, hopelessness is a terrible state for a human being.
Horrible.
And one of the reasons I did n-Lorem is the N of 1 patients are the most hopeless, most desperate, and just providing hope is a big deal. And something like Huntington's is something we can do.
Right.
There's never been any doubt in my mind that eventually we would be able to find a way to prevent the onset of symptoms and do that safely.
Yeah.
I'm absolutely confident that in due course that will get done. It just requires, a lot of complicated clinical trials to figure out when to treat, what to measure, and how to do that.
Well, and you're doing something that's never, well, I was going to say it's never been done before, had never been done before, which is to cure, a neurodegenerative disease, which, arguably spinal muscular atrophy was the first time in human history that we sort of turned the clock and cured someone who would have otherwise died of these terrible conditions. So I think we'll get there for HD too. I
do too. And that is the joy of doing the things I've done for a lifetime now. And so n-Lorem. I'm interested in how you heard about n-Lorem, and then just walk folks through how you came to be associated with n-Lorem and what you do every day.
Yeah, sure. So, I can't remember if I heard from Michael Hayden, my boss, who I know that you talked to at early stages about this, or Frank Bennett, that was involved, is involved as a CTO, who I still saw at HD meetings. But I had heard a kind of a rumor that in your semi-retirement, in quotes, that you were going to start this thing. And, being in the situation I was, where ASOs had offered such a huge lift to my community, it just immediately drew me, and I knew it was something I wanted to be involved with if I could. And so I basically followed Frank around at a meeting where we were both at, and sort of pestered him to sort of say, how can I help? How can I help? How can I get involved? And, at that point we were just trying to kind of figure out the best way to vet each case, or Frank and you and the other people involved were, and Frank brought me into that process, again, as you said, very early on. And we sort of had to figure out from scratch about how do we screen each case? Because of course, not just each gene, but each mutation is its own case, its own challenges, its own possibilities. And as we've learned, even if we have another n-Lorem case where there's someone with a mutation in that gene, another person with a mutation in that gene might not be eligible for very good and robust reasons for an ASO treatment. And that was a really exciting puzzle that we're still figuring out, and that I really wanted to be involved with. And sometimes it's easy, which is great, because you could say, yes, this is a dominant condition. And so, and sometimes it's more complicated, and it's been a real fun pleasure to be involved with that. So that takes place. So I'm part of a small group of people that help screen each submission. So it involves myself, who has background as basic scientists, fantastic clinician scientists that are both internal to n-Lorem as well as external advisors who are like world-class, amazing clinician scientists. And for each submission, each of us basically does a deep dive, a literature review. And it's not like we can just go to the medical textbook and find the chapter on, this incredibly rare mutation. Like we have to dig into the scientific literature. We have to reach out to experts. We have to look into the mouse and worm and fly literature and see if there's any other like model organism data that can help drive our decisions. So it's a very iterative, very careful, very thoughtful process for each patient, even if we think we know that gene, because each mutation may be different. And ultimately, the output of that is that we put together a presentation for a group called the Access to Treatment Committee, which those of us who are doing those screening work that I mentioned sit on, but also a lot of external experts from outside n-Lorem. And we have meetings every month for the Access to Treatment Committee, and we present our results. Oftentimes, the Access to Treatment Committee says, "That's great. Sounds like you guys did your homework. Yes or no, that you should go ahead with the recommendation to treat that patient." More than once they've said, "Oh, but you didn't think about this wrinkle that I know from my clinical practice in epilepsy of 20 years or whatever." And then we go back to the drawing board and we reincorporate those things. And they've been a great also source of like, have you spoken to so-and-so? I know someone who's the world expert on KCNQ2 seizures or something. And so they also are a network, and really everybody's doing their best. A lot of really smart people putting a lot of brain power into each case. It's really satisfying, even when unfortunately, as is going to have to be the case, a given case may not be eligible for treatment for various reasons. It's not because we didn't try.
Every patient matters, and it's one patient at a time. So, in that process, Jeff, if I forced you to tell me the three most important things you've learned, what would that be?
Oh my goodness.
I am forcing you.
I think we can learn a lot about genetics. We really have to understand exactly the genetics, and more generally, I mean like the mechanism of action, right? So the current way that we know that ASOs work best, there are certain types of genetic mutations that are more amenable to treatment. So understanding the mechanism of action is critical for a given mutation. As a sort of a side note to that, just because there's a paper that says something is a gain of function or loss of function hasn't always been the case when you really dive into it. And we've had cases where we've had like multiple iterations where we've discovered whole new areas that we have to go kind of read and learn about to figure that out. So I would say the mechanism matters. I would say that the speed and the progression of the symptoms matter. Maybe that's number two, because again, I'm not a clinician. I defer to my clinical colleagues a lot, but if we have someone with a very rapidly progressing form of ALS, for example, and we look at the timeline of trajectory of ASO development, and someone's at the very, very end stage of their life, what's most important to me as a family member is not to raise false hope in people. Substantive hope, real hope, is the most important thing in the world. False hope is the worst. And so if someone is one day away from dying of their condition, I don't want to tell their physician, yeah, I can make you an ASO in one day. That's just not feasible. So the state of the patient matters a lot. And I would say that maybe number three, hope is a very powerful thing. And I've been amazed at even when patients, when we think we can't help them with an ASO, in the conversations with their families and their physicians, it's been amazing impact of feeling seen, on those people who even if we say, listen, this is not an ASO amenable case for this very good reason, unless you tell us otherwise, it's still, I think there's a gratefulness that really surprises me. And so like, I'm amazed by the impact of hope and attention could have on someone's whole kind of sense of being, it's, yeah.
Yeah, our patients and parents are isolated. And they've spent years typically trying to find someone to listen to them and to actually care. And I think it's a combination of hope and caring, having someone else care about what happens to you and your family. So you're associated with n-Lorem like the rest of us because of the mission. And what would, in addition to learning the power of hope and learning the power of caring, what would you say the most gratifying part of this whole process is for you?
Oh my goodness. So I've said a lot about hope, so I'll take off my patient advocate hat and I'll put on my scientist hat. I mean, on top of helping people, this is such fascinating stuff, right? I mean, we're doing it because it matters for these patients. That's the motivation, full stop. But on the other side of that, what we're learning as I'm a biologist, and just like we're helping these people puts us at the cutting edge of like how mutations kill cells and how that leads to patterns of pathology that we call a disease. And that is so interesting and satisfying and motivating. And so it's like it's a whole bonus payment on top of the like, we're doing this because we can give substantive hope to patients and their families. As a scientist, then I get to turn around and say, gosh, I've just learned every week I learn about a new disease, and it's so fascinating, as a scientist. And the fact that not only could we learn that stuff, but we could also help people who are in this situation, that's what gets me up.
And as you know, I just submitted a couple of weeks ago our first real data paper, which is just a summary of the things that we learned from the first 173 patients that we dealt with. And I believe that in the long run, what we're doing will change the way we think about health and disease altogether. And as a scientist, it's thrilling to think about what we're learning and how taking advantage of these unique experiments of nature, which are single gene mutation patients, is going to affect everything in medicine.
Yeah, and it's almost a way of like paying back to pay back. But like rare disease patients, they're desperate because they're so unique, but what makes them unique teaches us a lot about the gene that's mutated in that person, which then maybe it's not the full cause of, say, Alzheimer's or Parkinson's, but maybe like learning more about this really rare gene will help us better understand those more common things. And certainly we're going to learn more about how to use ASOs effectively in different disease states. And so it's, in a way, the rare disease patients pay us back by undergoing these treatments, and that has broader impact for everyone's health, in the future. So I think that reciprocal kind of feedback of like trying to help these people because it's the right thing to do, full stop. And then we also learn all this amazing new stuff about how the body works and how to more effectively design treatments for everybody. It's such a cool payoff. I love it.
Me too. Me too. I guess I'll end by asking, maybe two questions. Are you looking forward to being treated one of these days for your incipient Huntington syndrome?
I fully expect to. These trials are happening. Every rare disease family knows this. At some point, you have to not give up hope of like, I'm going to cure myself or my kid, but like, if I woke up every day and was like, if I don't cure myself and my siblings tomorrow, I'm going to lose my mind. Like that wouldn't be a healthy place to be. And so like a lot of families, I probably got into some kind of equanimity about myself, like, because otherwise I'd go crazy every day when things went wrong and things went right in the lab and in the clinic. But I fully expect to have treatments in my lifetime, and I think it'll be something like HIV, where the first treatments will be a big advance, and then there'll be another one that uses a different thing that'll be a big advance, and then we'll put them together, and then someday no one will ever get Huntington's again. And I don't know if that's in my lifetime, but I don't care. Like, I think it'll be better for me, and it'll be much, much better for future generations, and that's kind of where I'm at with that.
Mm-hmm. Anything I haven't asked that I should have, or anything that you want to say to the folks who face immediately the issues you worry about facing someday in the future?
Yeah, I don't know. I guess if I was going to communicate one thing, I hope, that if, as I said, because substantive hope is based on sometimes having to say no, I hope that if families do hear no from n-Lorem after submitting a case, I hope that if they listen to this, they would realize that it's after a lot of really smart people think really hard about it, and we're always happy to be wrong, and if new science comes out, we'll readdress it. But I really hope that leaves people with a sense that, like, we're on their side, and we're fighting alongside them, and we're not some faceless pharma company that they don't know. We're rare disease families trying to do our best for every patient that gets submitted, and I hope as they get to know us, people will realize that.
Yeah. Well, this has been a very interesting conversation, Jeff. You've had, an interesting life, and interesting lives are always worth knowing about. And you have an interesting future, and that I'm absolutely confident that an ASO is going to be in your future, and that will make your future better. And I look forward to that for both you and for the broader community, and for the joy of helping. Thanks so much. And on behalf of all of our patients, you're one of the unsung heroes who actually work behind the scenes to do the things that must be done to help us decide whether we can help a patient or not, and to do it the right way.
Yeah. Thank you, Stan. I appreciate it. It's a great joy, and it's fun for me to talk about it as well. So thanks for taking the time.
n-Lorem is a nonprofit committed to discovering and providing personalized experimental treatments for free for life to patients with genetic diseases that affect 1 to 30 patients worldwide, referred to by n-Lorem as Nano-rare. Many of these patients progress and die without ever achieving a diagnosis. This is where n-Lorem comes in. They do the impossible by providing hope, and for those that they can help, free lifetime treatment. For more information about n-Lorem or today's episode, visit n-Lorem.org. Any questions can be sent into podcast@n-Lorem.org. Search n-Lorem on Twitter, Instagram, YouTube, LinkedIn, and Facebook to connect with us. This video is hosted by Dr. Stan Crook and produced with the help of the following professionals. Thank you for watching.